Hello, welcome to my channel. Today we are going to learn the second derivative test and one example from the second derivative test. Okay, so what is the second derivative test? To apply this test, first we need to find out the critical point C. So f prime of C must be 0 and if f double prime of C is greater than 0, then the function is concave up. And if a function is concave up, it will have a local minimum at that point. If f dash of C is equal to 0 and the second derivative of f at point C is less than 0, then the function will be concave down. And if a function is concave down, it will have a local maximum at point C, means at that critical point. Okay. Now let us take one example. Suppose our function is f of x is equal to x cube minus 3x square plus 2. First we need to find out the critical point of this function. So let us find the first derivative. F dash of x will be equal to 3x square according to power rule minus 3 will be as it is, and according to power rule derivative of x square would be 2x. So 3 times 2x would be 6x and derivative of constant 2 would be 0, so no need to write it. Now to find the critical point, let us set this function is equal to 0. We can factor out 3x from both the terms. So in the parenthesis we will have x minus 2 which is equal to 0. So after solving this equation, we can get x is equal to 0 and x is equal to 2. So now we have two critical values, 0 and 2. Now let us check the second derivative test. To check it, first we need to find out the second derivative of function f. So f double dash of x would be equal to, here 3 will stay as it is, and according to power rule derivative of x square would be 2x. So 3 times 2x would be 6x minus derivative of 6x would be just 6. Okay, so what we can do is we can factor out 6 from both the terms. So we will have 6 into x minus 1. Okay, now let us draw a number line. Okay, this is our number line. Here you can see that if in this equation 6 times x minus 1, if we will plug in x is equal to 1, then it would be 0. So for all the values less than 1, we will have the sign minus. And for all the values which are greater than 1, we will have the positive sign. So here our f double dash of x will be negative from minus infinity to 1, and from 1 to infinity our second derivative would be positive. So here we will have maximum value, local maximum, and in this interval we will have local minimum value. So now let us check this by plugging in the critical points into the second derivative. So for x is equal to 0, our f double dash of 0 would be 6 times 0 minus 1, which is minus 6, which is less than 0. So our function f will have local maximum at point 0 and our function will be concave down. Now let us check it for x is equal to 2. So let us take x is equal to 2. So our f double dash of 2 will be 6 into 2 minus 1, which is 6 and which is greater than 0. So our function will have local minimum at this point and our function will be concave up. Hope this will help you to understand second derivative test.